So in this video, we're going to cover the Unit 2 practice benchmark to review for our test coming up. So go ahead and start right here with this document. If you need more practice on any one of these topics, I want you to remember, keep this in mind. If you get stuck and you're like, wait a minute, I almost got that, but I need another example, just go watch one of the other videos on that same topic. I've posted a lot of them, so don't forget to use those too when you need more examples, all right? Also, on Google Classroom, you'll notice that I put another larger practice set, so if you need extra work, you can go look there too. Okay, let's go start doing this problem by, again, considering what this means. Okay, so an arithmetic sequence adds the same value every time. So this has what we call a common difference, okay, or a constant difference, either way. Okay, and the geometric sequences have a common ratio. Okay, so understand there's a difference, right? This one means that we're adding or subtracting, and this one means that we're multiplying by some kind of value, okay? Whether or not that's bigger than 1 doesn't matter, okay? Just multiplying by some value. So let's take a look, okay? Is this adding the same thing every time? Well, 1 plus 8 is 9, okay? So we want to see, is 9 plus 8 equal to 25? No, 9 plus 8 is not 25. So that means right away I can cross out arithmetic, okay? This cannot be arithmetic because there's no common difference. It's not adding the same thing every time, right? 9 plus 8 is not 25. So the next thing to think about is, are we multiplying by something? Okay, so 9 times 1 makes 9. Good, okay. Is 9 times 9 25? No. So that means that this cannot be geometric either because we're not multiplying by the same thing every time. So that tells me that the final answer here is that it's neither. Okay, so don't forget that it's possible that it doesn't add or multiply the same thing every time, in which case you got to choose neither. Okay, so we'll jump back into this number 2 and think about what you should have here. Is this adding the same value every time, or is it multiplying the same value, or is it doing neither? Okay, I'm hoping you can see it's adding 10 every time, and so we have a common difference of 10, and so it's arithmetic. An arithmetic sequence is what we have here. Okay, this next one, I want to emphasize the difference between the format, okay? On your paper, you probably have something that looks like a sub n and a sub n minus 1. But what you guys should see is that it's the same thing as having f of n, okay? So this is just the same notation. I'm just turning the a sub n into f of n, and f of n minus 1 comes from a sub n minus 1, okay? So let's break this down. For each sequence, state if it's arithmetic, geometric, or neither. So all we have here is this recursive formula, okay? And this one tells me to get the next term, you take the one that came before, right, the n minus 1th term, the one that came before it, and then multiply that by negative 2. So think about it. It's telling me the first term is 3, and to get the next one, you multiply 3 times negative 2, okay? So when you're multiplying by the same thing every time, that means you have a geometric sequence, okay? So this one is geometric. You got me? Now, we'll take a look at number 4 and notice that I didn't change this format to look like this, right, where I have f of n. So we want to understand that this a sub n is the same thing as f of n, a sub 1 is the same thing as f of 1, and a sub n minus 1 is just f of n minus 1, okay? So when I change this, it's just going to look, okay, so notice that we just made it look like that, okay? So all I did was change this little notation. So you'll see that other notation occasionally, so I threw it at you every now and then so that we could see that there's a connection between the two. So now think about it. What is this doing to every term? It's telling me to get the next term, take the one that came before, right? Okay, and add 200. What does that mean when we add the same thing every time? That means it's arithmetic, okay? So notice this recursive formula is what I'm testing you on here, is do you know how to read that? And can you recognize that this thing right here means add 200 to whatever came before to get the next one, all right? So that's all that means, right? Okay, so we'll continue moving through these problems. We can see here now that we got to get our common differences. So the common difference in this case is positive 7. Notice it's increasing by 7 every time, okay? Another way to get the common difference is to take a term and subtract the preceding term. So 27 minus 20 gives me positive 7. Okay? So again, the common difference is something that we should be able to do by using subtraction or by just counting upwards, right? What do I have to do? What do I take away from 33, from negative 33, to get negative 42? Okay? And so you can see this one is a negative value. It's negative 9, right? If I subtract 9, then I'll get negative 42. And notice it's subtracting 9 every time. Okay? So just be careful on these ones. Just make sure you count and choose the correct number. Okay. Now that we get to this problem, I know we probably have to talk about how to do some substitution. So let's look at this. Okay? Now we said that in this case, that A of 40, we got to understand that that's the same thing as F of 40. That's the same thing, okay? And so A sub n is the same thing as F of n in this notation that we have here, okay? And so all this means is the same exact equation, okay? But it wants us to plug in 40 so that we know what the 40th one is, right? So I want to find F of 40. So what that means is I'm going to go change this n into a 40. Again, I'm trying to get you guys to focus on those two n's both being n's. Okay, well now they're both going to be 40. So we got negative 23 plus n minus 1. Okay, but the n is 40. So we got 40 minus 1 times 100. Okay, this is negative 23. And then we should calculate 40 minus 1 is 39. So we have to do 39 times 100. Okay, but that is just 3,900. And we should recognize that this is the same thing as just 3,900 minus 23, right? So you should be able to find your answer pretty quickly, seeing that we have this one right here. Okay? So this example is just using the explicit formula to make sure that we can get something. All right? Now finding the common ratio here, we should see it's multiplying by 2 every time. So our common ratio is 2, right? 3 times 2 is 6, 6 times 2 is 12, and 12 times 2 is 24. On this case, we have an alternating sequence, and we can see it's getting multiplied by negative 3 every time. And so notice when we have a negative value that's our common ratio, we'll have alternating negative, positive, or positive, negative, either way. That has to happen if we have a negative, all right? So taking a look at this one, it's time to substitute in a value and calculate this one by realizing that all we have to do is get f of 8, right? So this is the same thing as f of n equals negative 2 to the n minus 1. But since I want to find f of 8, because I'm finding the 8th term, right? That means that I just have to plug in negative 2 to the 8 minus 1, okay? And 8 minus 1 means 7, okay? So that means I got to do negative 2 times itself 7 times. That's kind of a lot, right? To do negative 2 times 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 negative 2. So in this case, we can see that we'll find our answer, but again, you should use a calculator to do this. So here we go. You guys should find that your answer is negative 128. Go. So I just switched the way that I was doing this problem. So notice that we're going to calculate this again, and I'm going to do it right on top, okay? We want to find the 8th term, so that means I want to find f of 8. And to do that, that means I'm going to change only the n. So the n is now going to be 8 minus 1 instead of n minus 1. Okay? So notice the only thing that changes is now that we got 8 minus 1 is 7. Okay? So negative 2 to the 7, if we calculate this, we should be able to use a calculator and do this correctly. You should get a negative value. Okay? And if you look through these, you will find your answer of negative 128. Okay? So, again, just understand that A sub n just means f of n, and that's all that is, okay? It's the same thing that we've done before. So in this example, we would want to plug in our value, right? We only want to plug in our value for n, okay? So if I have this formula that f of n is equal to 3 times 6 to the n minus 1. But then I want to find f of 8, because again it says to find the 8th term. Then that means all I have to do is change the n into an 8. So we got 8 minus 1. And so that gives us 3 times 6 to the 7th. Okay? You want to do that in your calculator, you're going to get 3 times 6 to the 7th. So you do 6 to the 7th in your calculator, get that value, and then once you have that, you multiply it by 3, and you'll get an answer. Okay, the answer that you should get for that would be 839,808. Okay? So, we'll continue. So now we look at number 12, and we see that this problem is a substitution problem. And so, all we want to do is change, right? It says at x equals 1. Okay, so we're going to go take this 1 and we're going to plug it in right there for x, right? So instead of copying the x, I'm going to put a blank parentheses. And what number should go in there? 1. Okay, because we're looking for when x is equal to 1, right? That's what tells me to change it. Okay, so what's 4 times 1?
4.
4. And what's 4 plus 1? 5. Okay, so we should have a value of 5, and we can see, oh look, that's right here, that's A. Okay, so there's one substitution problem, but then there's again another one where you're probably going to have to substitute in using function notation. Okay, so let's make sure we understand this one. Okay, I probably won't put one this easy on the test, but I put it on the homework so that it would be simple. Okay, g of 10 is equal to 10 plus 5. Okay, we should recognize that. Look at what's different, right? We're changing the n into a 10, right? And so the n should change into a 10. Again, what's 10 plus 5?
15.
15. Okay, so we should have B. Okay, we got an interactive YouTube video. Some of my students are here following along. All right, so 14 right here, okay? You might want to pause this video and see if you know how to do this one. You should be able to do it in your head even, okay? But if f of n is equal to n plus 5, okay, and I'm substituting in 1, then that means I got to do 1 plus 5. And 1 plus 5 is 6. So this just gives us 6. All right? So we're doing all right with this Unit 2 test so far. But we have a couple more things to deal with, okay? So now we're talking about functions. I have a lot of videos we did on this lately, and we hadn't been tested on any of it, right? None of those ideas were tested on. So now finally you're getting tested on them. So we have these two, we have this set of input and this set of output, okay? So what you guys are supposed to remember is for it to be a function, we have to make sure that every input only has one output. So I can see 3 only has 1, negative 1 only has one output, 1 only has one output, 6 only has 1, and 7 only has 1. None of these inputs have 2 outputs. So that means that we have a function. Okay? So we continue moving on to 16, and we see I changed the words from input and output to now domain and range. Okay? But I'm hoping you can see this time that the negative 3 definitely has 2 arrows leading out of it, right? So this one right here has 2 outputs, okay? That means this is not a function, okay? It cannot be a function if an input has 2 different outputs, okay? The same way we said before, when we put the orange juice into the juicer, I want orange juice to come out, not blueberry juice or something, right? So, we keep moving. We got 17, okay? Is this a function or not? And you guys were supposed to remember this thing called the vertical line test, okay? If any vertical line crosses our graph in more than one place, then that means it's not a function. Does this line cross in 2 places? Yeah. So this is not a function. Okay? That would mean that when I plug in one of these numbers, like negative 4, I get 2 different values. And that's confusing, so that means it's not a function. Alright? So next thing we're going to do is move on to 18. Okay, and I recognize this video will be on YouTube later, so all you guys chatting it up, you guys can check yourselves out on YouTube later too. Alright? There we go, yeah. We got him out here. Alright, so the next one, okay, this one. Does this pass the vertical line test? If I pass a vertical line, does it ever cross in more than one place? No. Okay? So this is a function. All right, 18 is a function. All right, now I know I might be doing some of these quick, and if you guys want extra practice, I got another assignment that I'm going to add to Google Classroom for those of you that want extra practice. I'm just not going to print it because I know everybody probably won't use it, but it's digitally there, and you guys can use the digital version to practice anything that you want because I got all of the, the answers to them too. All right. So notice we have two holes in this one, right? This one and this one are both holes. They're not solid. So when that's filled in, we could have the little line underneath, but because it's not, we should have a strictly less than or strictly greater than, right? So that tells me what can I cross out already. I know I could get rid of this one because that has the little line underneath, okay? And then it looks like the rest of them on domain don't have anything special, so now we better go look at these numbers, all right? So let's go look at the picture, all right? This number right here is positive 5, and this one right here is negative 7. So what's happening there? Okay, this is telling me that my domain would be values that are less than 5, but are greater than negative 7. Okay, do you guys see any of those up here? Is there more than one possibility that looks like that? Well, it can't be C. So again, it's between B or D. Okay? And again, we're just looking at the X values right now. So what do we need? We have to make our mind up by looking at the range values now. Okay? So what's the highest value? 1. And what's the lowest value down here? Negative 3. Okay? So do we see that anywhere? With a Y in between that? Come on, get rid of that, please. Huh? All right. This would be D. All right. So all of my students are following along 100% right now. Yeah. I hope that this is getting easier. So for number 20, again, we should recognize that one of them is full and another one is not. But if you go watch the videos on Introduction to Functions, okay, on interval notation and inequalities, you should be able to get these. Okay. Now notice that the leftmost point is negative 5 and the rightmost point is right here at negative 3. Okay. So I know that we're in between negative 5 and negative 3, and the only one that even has that is D. Okay, so I'd have to go with that one. All right, so now we'll take a look at 21, and we're making good time on this thing. So now we have this thing called interval notation. I hope you guys can remember that we had mentioned that when it is a solid point like that, right, then that means that we're going to use the bracket like that. But we said when it's a hole, then we end up only using the parentheses, right? So let's go look at what we got here. Okay, this is a hole, and this lines up with 4. Okay, so that tells me I'm going to have around parentheses with that number 4. Okay, what's going to be on the other side though? I can see this point is the leftmost point. Remember, we want to find the leftmost and the rightmost point. The leftmost point is at negative 4. So that means here we're going to have negative 4, and because that's solid, I have a square bracket. Okay, so that's the first one, and it looks like already we could already choose the right answer from down here. Okay, this is the domain. Again, it's the leftmost point from the rightmost point. We do those two. Okay, remember the range was the top and the bottom, the maximum and the minimum. Okay, what's the minimum point?
6.
Negative 6. That's solid, so it's a square. So there's negative 6. Okay, what's the highest point?
6.
Positive 6, but that's a hole. So I got to have around parentheses and put a 6 right there. Okay? Do we see that option anywhere? That's B. Okay? So 22 I'll probably leave as an exercise for you guys. You guys do have the answer, so you guys can work on that one on your own. Okay? And now we get to 23 with something pretty simple. So this was me trying to take some of the Unit 0 ideas and test you guys on them. Okay? So the way to do this is to remember that you got to do the parentheses first. Alright? So what's 1 plus 3? 4. 6 times 4? 24. Okay, so there's a couple really easy problems on here, but you just got to show me that you know the order of operations, the whole PEMDAS thing, right? Parentheses, exponents, multiplication, division, addition, subtraction. All right, that's going to be on there too. So 24, we'll do this one together to make sure you guys got some kind of a example. Okay? 6 minus, and then 4 minus 1, well, 4 minus 1 is 3. And 6 minus 3 is 3. So, you should have B right there. Okay? Which ones? Okay, that's kind of weird. I'm not sure why that is, but we'll talk about it later. Okay, excuse me. So everybody, we'll just stick with me right now anyway. So for these problems, we can see that we're looking for domain and range again, right? Notice that we want the leftmost and the rightmost, okay? The rightmost is 6, right? That's a solid, so it's going to be a square bracket. But notice this line is going to go on forever to the left, so there is no leftmost point. So that means it's a round parentheses, and it's infinite. So our domain goes from, sorry, not infinity, but negative infinity. All right? From negative infinity to 6. And then now for our range, we should be able to see what's the minimum value of this function. The minimum value is right here. What's the lowest value? It's at 0. Okay? And is there a maximum value or no maximum value? Is this thing pointing up? And it's going to go up forever. So there is no maximum value. So we just have infinity. And we put a round parentheses there, all right? Do you guys see that option anywhere? Okay, I see that right here on option C. All right, so there's a little bit of infinity on there for you guys to deal with, but I think you guys can handle it. All right. So now we get to this one. And I got, a lot of theories about what's going to happen on this problem, guys. So let's take a look. All right, I'm just going to go ahead and leave it like this. So, what's this look like on your paper? Okay, so anyway, just look up here. All right, what's going to happen right now on these problems is there's going to be a graph given to you, and then it's going to ask you to figure something out. Notice it says domino 10. Can you guys all underline domino 10? All right, everybody go underline where it says domino 10. Underline that. All right. Then, what you guys got to realize is what you're going to have to do is go follow 10 up to that line and see what number that traces back to. Okay? So I'm not totally sure what happened here. I was supposed to give you guys the graph, but it looks like it didn't come out. So something happened with the color. I think it was printing in red, and something happened with the black and white. So I'm sorry, but your graph should have looked like this. Okay? And all you have to do is look at the number that it says. If it says domino 9, then you're going to go look at 9. If it says domino 8, then you'll go look at 8 and see what it corresponds to for the y value. Alright? So, that's what you guys will have there. Okay, that one's not too complicated. And now we get this value. Okay, and we were talking about graphing this discrete domain. So here's the way this works. Okay? This function is telling us to graph f of x equals negative 3x plus 2. All right, you guys out of control with the talking now, so please don't get my attention anymore. That's enough. All right, so here we go. What we're going to have here is negative 2, 0, 1, 2, and 3. Okay? All we have to do is plug those into this value and see what they're all going to be, right? So I'm going to plug in each one into this equation, negative 3x plus 2. So this one's going to be negative 3 times negative 2 plus 2. This one's going to be negative 3 times 0 plus 2. This one's going to be negative 3 times 1 plus 2. You guys see my point? Okay, so just write them all down so you guys know what to do. All right, so now what's a negative times a negative? Negative 3 times negative 2? positive 6. And positive 6 plus 2, salute, okay, is 8. Okay? So, we just keep going down the line. So, 3 times 0 is 0. 0 plus 2 is 2. Okay, so this is giving us the points that need to be on the graph. This is saying that if I plug in negative 2, I should get positive 8. Okay, so let's look at this one. I plug in negative 2, does this give me positive 8? No. So it can't be that one. When I plug in negative 2, does this one give me positive 8? No? Okay, so it can't be that one. When I plug in negative 2, does this one give me positive 8?
Yes.
Yeah, so what's the answer? Okay, it's going to be that one. You guys see how to do this, okay? It's really just about being able to read the problem, plug in a number, and count your way to the end. All right? So, you can continue going through and getting the rest of them again. Negative 3 plus 2, okay? Negative 6 plus 2, and negative 9 plus 2. And you're going to see they're all going to give us different coordinates, okay? And you just put them down and check if they're correct, all right? Okay, so 29, I'll let you guys check that, but again, the answer for this one is B, so you can double check that one on your own. Okay, and now we get this little simplification problem. Okay, and on this one, I'm expecting you guys to know what happens if I count K together, right? This is the same thing as 5K minus 6K, okay? And so think about it, if I take away more than I have, then I got to end up with negative, okay? So this is negative K. And in this case, you would just pick B. Alright, so it's just combining like terms in that case. This idea, right, that x plus x equals 2x, right? What's x plus 2x? 3x, okay, so we're just adding x's. We're just counting how many times we've added a value, alright? Let's see how close we are to the end here. Okay, so in this case, you have just another simplification. We'll go ahead and do this one together, why not? Okay, so here, we should realize that, you know, the 2 can't change, okay? But 2r minus 8r is going to give me minus 6r, okay? So be careful and make sure you choose A. Make sure you're thinking about what you're doing. I think we got maybe 1 or 2 problems left here before we're done. So this one is called the distributive property. Okay, so to wrap this up, what we're going to do is multiply this times both of these values. So I usually show that with these little lines, okay? Negative 3 times positive 1 makes negative 3. Negative 3 times positive 4m makes negative 12m. Okay, don't forget I got to do the 3 times the 4, and it's a negative 3, so that's why I get a negative value. Okay? Hopefully you guys can see that the answer is option C. All right. We're doing good. We got done with this one, okay? So if you need more examples, please refer to Google Classroom and see the longer review, all right? Good luck studying.